Nice. And just to clarify, we are not the team behind PYUSD, that is PayPal. We are the developer platform that you can use to build in this hackathon. Start building some cool applications with them.
All right, cool. Thanks, David.
Of course, let me go ahead and share my screen. Awesome. Cool. Well, thank you for the introduction, and we'll start diving right in. And I'm going to go ahead and quickly turn off my video. There you go. Great. So we'll talk today about a little bit about Portal, what Portal is, how to use Portal to build Web3 applications. And we'll also talk about PYUSD, what that is, and how you can use it to build some awesome applications for Hackathon. If you have any questions, just go ahead and unmute yourself and ask me during the middle of it. And I'll save some time at the end for questions as well. So just starting with some of the information about the hackathon, you can go to the link at the bottom here to learn more. So yeah, we're in a partnership with PayPal to help folks build applications built on top of PYUSD. If you go to that link, there's a ton of info about the prizes, the format, everything. And there's a bunch more content there as well in terms of videos, demos, more information. Just give a brief overview of the timeline. Hackathon started a few weeks ago, but it's still continuing. So plenty of time, just keep building. And then there's a judging window from the 16th to the 29th. And here are the prizes. Just pulling this off the page to share with everyone here. We'll be judging the projects on a different set of criteria, including originality, applicability. So it's different subcategories, which always makes it interesting to explore different opportunities and doesn't always have to be kind of the same app across the board. But with that basic info out of the way, let's dive right in. So what is PYUSD? So at the highest level, PYUSD is a stablecoin that is pegged to the US dollar. It is launched on Polygon, Ethereum, and Solana, which we'll be talking about here. And on Solana, it's implemented as an SPL22, which is the Solana token extensions. And so if you'd like to learn more about PYUSD, highly recommend going to the Hackathon Hub page in our docs, which continues to have more content there. But if you're familiar with stablecoins, pretty straightforward. If you're not familiar with stablecoins, just as a quick overview, stablecoin is a type of smart contract deployed to blockchain. So whether it's an ERC20 in EVM world or an SPL or SPL22 token in Solana, and allows you to create tokens with different purpose. And for stablecoins, they're always paid usually just with fiat currency. And so for PYUSD, similar to USDT or USDC, it's paid to the US dollar. And of course, PYUSD is backed by PayPal. And just as a quick overview, it's one of my favorite links in this page of support documentation is this technical deep dive into PYUSD on Solana's developer docs. So I highly recommend if you want to learn more to go there. I had a cool walkthrough video on how to build with PYUSD. If you want to build your own smart contract to operate with it, we'll be talking about smart contracts today. We'll be talking about building Web3 applications from the client side. There's fantastic information there, including the token addresses, looking for that, looking for faucets to get some test PYUSD, and more technical explainer behind PayPal's motivation and some of the features, especially on the SPL22. And for those who aren't familiar, difference between token extensions on Solana. If you're familiar with ERC20 tokens, an SPL token is the same thing, but they come in two different flavors. So the SPL original token, and then there's the token 22 or token extensions. It's the same thing. And those are just tokens built with extra features built into it. A lot of cool additional functionality is built into it, and so you'll see both in Solana is built on the newer standard, the token 22. And just as a quick insight on what you'll find on the PYUSD Hackathon Hub, you'll find links to all of this information here. So like I mentioned before, you can find the address of the PYUSD SPL contract, the program on Solana, also address for the DevNet. So if you were to start building, go ahead and use that PYUSD Solana DevNet address plus the PYUSD and Solana faucets at the bottom. You have all the things you need to start getting some test tokens and test Solana and start building the application. And so before you go into Portal, I'll actually just take a minute to pause here. Any questions about PYUSD before I continue? Great.
I think at this point, yeah, they don't have questions. But regarding the documentations, David, where can they find it? The resources.
Yeah, so let's see. All the documentation is available at docsportalhq.io/support/PYUSD-hackathon-hub. You'll find all this helpful information there.
All right, perfect. Thanks, David.
So let's talk about Portal. So Portal is a developer platform that you can use that helps build embedded wallets, specifically through MPC wallets. So let me take a quick second to talk about what MPC means. So MPC stands for multi-party computation. And the cool part about multi-party computation is that instead of having one private key, you have multiple private key shares. And so I'll walk through that here right now. And then after this, we'll go through some of the developer docs. So this is kind of like a rough view of how MPC works and how key management works with Portal. So first, there is no private key. There's no single private key. There's actually these two shares. So one of these shares, after you run this generate command, one share will live on a user device and one lives with Portal. And this kind of assumes you're building an application for consumers. So you're working with Portal and your product has users. So you'll build your client application. That client application will talk to our backend. Trying to use the device at one Portal and signing a message. So in other words, to get access to any of the funds associated with this wallet requires both shares to be involved. And they both have to communicate at the same time. So the really cool part about this is that when we've generated these two shares, this is where the multi-party computation comes into play. The key shares are generated on both devices without either one ever having been on one device. So this is not as simple as creating a single key on the Portal backend, cutting it in half, and sending it to the user. In this case, these shares are coded to each device via a series of mathematical proofs sent back and forth between each device. This provides a really strong security guarantee. The shares never exist in one location. If portal's compromised, only one share is ever exposed. If the user's device is ever compromised, only one share is ever exposed. So it gives you like a really strong security guarantee that you can't have your single private key stolen, for example. So there's no seed phrase because there's no single private key to lose, to get phished, to get hacked. If the one share is compromised, your funds are still safe. You would need both shares. But of course, what happens if a user loses their phone? Well, this is where backup and recovery come into play. So I'll gloss over this. This isn't super, you don't need to know this information if you want to start building for the hackathon, but just to give you information about how this works. You actually generate recovery shares. And these recovery shares can only be created by using those two original signing shares. So you'll create these two recovery shares, one on each device. You'll encrypt one of them, and then both get sent to Portal. They can see that Portal has the two recovery shares. Well, that's okay because one of them's actually been encrypted, and the key it's been encrypted with lives on the user's backup system. So whether that's you have integrations for Google Drive, for iCloud, you can use password to do password-based key derivation, and we also have passkeys. Using any of those four methods, you can encrypt one of the recovery shares and send both to Portal for us to securely store. So in the event that a user loses their device, once it loses their share, well, we can initiate the recovery process and it'll generate this new set of signing shares for the same address. So the user's device will authenticate with Portal and will return that encrypted recovery share. The user will go to their personal storage, whether it's Google Drive, iCloud, just entering their password or using passkeys, and they can pull in their recovery key, decrypt the recovery share. And now we're back in a situation where the user has a share on their device, Portal has a share on our device, and we can use those to go ahead and generate new signing shares. Of course, this is all secured with authentication along the way. So that between each hop, so whether you're connecting with, let's say, Google Drive or iCloud over OAuth, communicating or authenticating with passkeys, or you have your password. And then all communication to the user device and Portal's backend happens with a session token. And all the storage along the way is also protected. So all material stored in our backend, encrypted at rest at the application layer, and all authentication on the user's device requiring biometrics stored in the mobile keychain. So that's a pretty quick overview of how MPC works. We do have additional docs on our website. I'm always happy to talk more about MPC. Super fun to nerd out about that stuff. So if you have any questions, let me know.
So we have a question, David, sorry to butt in.
Nice.
Regarding MPC, so Pilex asked, what happens if Portal suddenly disappears?
Incredible question. So in this configuration I showed here, let's see where to go. I showed Portal as holding both of the recovery shares. So there's two things. First, this is the simplified version of how we store it. There's actually an option where instead of Portal holding backup key material, you can set up a webhook server on your backend to hold it instead. And so in that case, you add a little bit of resilience where if Portal goes down, you host both these things. So now you have a relationship between you and the user where all the key material is between you. So you add a layer of resilience that way. That's an additional configuration. So I just kept that out of this diagram, but there's two options that are available. You either have Portal host it, maybe you're just getting up and running, developing. So you want us to take care of that. Then maybe you're rolling out and you want to have more security guarantees. And so we can send a webhook and send those backup shares to your backend. So that's like architecturally or we would distribute the key material to protect against that. In terms of data resilience, we have point-in-time backups that we can rewind anytime, backups across multiple regions. So yeah, we do quite a bit on the back end to make sure all that stuff is safe and protected. But in terms of like the architectural design, yeah, you can store the key material on your own back end if you'd like.
So he has a follow-up statement, I guess. So the user could theoretically use a third entity to keep another set of backup shares. I see.
So we haven't, using our SDKs, we don't expose it in a way to give the user the option to set that up. However, we're going to be sending the backup shares to your backend for you to store. And from there, yeah, you could set up ways to store those recovery shares somewhere else. Now, I will call out the caveat that if the user is in control of both recovery shares, then at that point, if they have both recovery shares, let's say they were to store them in the same spot they stored the recovery key, Google Drive, now all the key materials in one place. So you do risk now, you've kind of pulled apart the value of MVC, right, of storing things in multiple areas to prevent bringing them all into one area to be compromised. But if that third party was another place that required authentication, yeah, you could distribute the key material that way.
All right, cool. Thanks, David.
Yeah, great question.
Thank you also, Alex. I think we can move on.
Cool. Let's start going through some of the docs then. So first, here are our developer docs. And I'll go ahead and walk through some authentication and then start explaining the setup we have for our web SDK. And just as a high level, we do have multiple SDKs you can get started with. So we have React Native, we have iOS, we have Android, web, and we also have an API that's powered by secure enclaves. So let's start with the authentication. So there's two different pieces of authentication that we use at Portal. The first is the Portal API key. This is your traditional server-side API key to have your backend talk to our backend. And then there's the client session token, also known as the client API key in some of these docs. But given by its name, the client being the user's device, this lives on the client's device on their client and is used to authenticate the users of the SDK. And so what you'll end up using these two things for, the Portal API key is going to be used server-side to create new client session tokens. So after like a user authenticates to your backend, you can use that to use our Portal API key to generate them a session token to forward onto their device. And you can also use it to fetch information about the different wallets that you've created. And then once the user has their client API key, this is used to initialize the Portal SDK on their device. And then this is what handles all the authentication for our all the MPC for our API and for all the MVC operations. I think this diagram down here shows it best. So this would be a typical configuration for setting up authentication. So you have use device, and this is running either your website that you built or your mobile app. And the user will log in using customer authentication. And once they've logged into your backend, you'll use that Portal API key to create a new client, and we'll return that session token. And you return that session token back to the user's device. And that when the SDK is now utilized in the client application, it'll use that session token to authenticate to our backend. Now, for folks working using or building for the hackathon, we actually simplify this a little bit, so we can skip this entire dance if you just want to start building a client-side application. So if you go to our admin dashboard and go to our settings page, you'll see there's actually a place where you can create a test client API key. The client API key being the same thing as the client session token. So you can create a test version of that. It'll spit one out without you having to go through this dance to the back end. And this is also in the settings page where you can go ahead and generate the API key if you want to start building in that back end. So with that, we can jump into we'll step through the web SDK, what it would look like to start building on it. That's very simple. For the web SDK, just use Yarn to go ahead and add our package. For all of the other SDKs, similar packaging managers to get started. And across all SDKs, you'll see the similar pattern to initialize portal. So it's typically as simple as what you see here. So you'll instantiate a new portal object, and in this API key, this is where you'll put that client API key, that test client API you created, or the client session token you returned from your backend. And once you've added that, that's a key piece of material to get started. So this second configuration here, auto approve, that will just a setting to turn on and off whether you want signing requests to get automatically sent to our backend, or if you want to instead put a modal in place to prompt a user to show them what transaction they're about to sign, which is covered in the custom signature hooks section in all of our guides. And then this RPC config, by default, we'll automatically submit requests to specific chains to a default RPC gateway. But we do that with limited support for rate limits. Those are kind of like just helpful to get started. Once you want to start scaling your application, you can go ahead and go to a site like Alchemy or Infura, QuickNode, and get an API key and a URL for their RPC config, and you can put it in here for any of the chains you want to support. This format here is just showing, okay, for mainnet, for Ethereum, this is the URL you put in, or for Solana mainnet, go ahead and use the default gateway URL here. Like I mentioned, you'd actually don't need to set anything in this configuration if you're just getting started for the hackathon, because we'll automatically take care of that on the back end. So now that you've got Portal created, let's start looking at what it would take to create a new wallet. So for the web SDK, we've built several like handy React helpers in here. In this case, there's the onReady. And so you can use this just to check to see if Portal's been finished initializing. And then creating a wallet is as simple as this, portal.createWallet. And that goes ahead and starts that MPZ communication I mentioned before. So when you call this function, your user's device will open up a WebSocket connection with our backend, authenticate with that session token, and the user device in our backend will start sending a series of messages back and forth across that WebSocket to generate these shares on either device. And you can see we have these helper functions here just to see, hey, has a wallet already been created for this user before going ahead and trying to create one. Because you can only create one wallet per client, which is a helpful thing to know if you're working in the hackathon, which means that if you get that test client API key and you're creating an application to test with and you create a wallet and then you try to create another one again, you'll get an error. So just go ahead and create a new test client API key in the admin dashboard there. And once you have that, the signing share is stored, securely stored on your device. And now you can start getting the different addresses. So if you're working on any EVM chain, you can get the ETH address here to get the EIP 155 address, or you can get the Solana address. And quick information on what EIP 155, why it says that instead of mainnet or Polygon. We use the chain agnostic protocols, CAIP, which are linked in here, which help describe how you describe or reference chains across the entire ecosystem. So EIP 155 is a part of that. It's basically EVM in the chain agnostic world. So going back to this is as simple as enough to create your wallet. And then here, actually, I'll just pull this up in the admin dashboard. So here's our web app. This is just a test organization I created. And you can see here's that test client API key button. So we click here, that's where you can get some test credentials to get started. So where do you then create a wallet? And now start looking at what signing looks like. Because once you've created a wallet, you're good to go. Start building out transactions and signing transactions. So using the portal.request function, you can submit any of the RPC methods for the chain you're interacting with. So if you're using EVM, you can see we're sending Ethereum RPC methods over to go ahead and sign that transaction. But the same thing with Solana, just provide the format for the Solana RPC, and you can go ahead and get signing. And let's see, I was going to show. Let's see if I go to the iOS page. I think we have a good example. Yeah. So this is for our iOS SDK written in Kotlin. But you can see just some example code of how you would submit a transaction to Solana. So you can build your Solana transaction, and this would be the same for any of the repos. Go find a helpful Solana repo to, or a Solana library to build your transaction. And then right here, just portal.request, pass the information, and you'll get your transaction hash back. So that's core. This is how you would interact to build these. And if we go back to the web SDK, you can see you can also then use, we have a provider class in all of our SDKs. If you wanted just to wrap around, let's say, you're using ethers, for example, and you wanted to put that into like a different SDK, you can go ahead and wrap this provider with our portal provider, and you can start using the ethers abstractions to do any of the signing you want with portal. At this point, I'll call out actually some really cool functionality we've built. So if that looks like a lot, and don't worry if you're not familiar with Web3 development, that could look like a lot. What are these RPC gateways? What are all these functions? What are all these params? We've actually created some really cool helper functionality. So there's some SDK functions that are getting incorporated into the SDKs. But these API functions have some really cool helpers. Let me call out two specifically. So first one I want to call is build a transaction to send asset. So if you're looking at all of that, how do I build a transaction? I need to go take that before getting assigned. We can actually help you with that. And so we have a single endpoint that you can send a request to, and you just say, I want to transfer an asset. I want to send it somewhere. So in this case, you can just say, hey, I want to use it on Solana, and I want to send a user some amount of token. And that could be either the native token Solana, or it could be, in this case, PYUSD. And by simply sending this request, what it will return you is the formatted transaction you need, and you can take that and just pass it to the portal sign, and you're done. So this is an extremely helpful way to get started if you don't want to go play with different Solana libraries or figure out the transaction gets formatted. If you are interested in all this stuff and you're familiar with that, all of that's available to you to start building. But if you're not, this is a really, really helpful way to get started. And you can see by sending it, it'll return this information. And all you would need to do is take what's in this transaction, pass that into the signature, and you now have you submit a transaction to transfer assets. While I'm here, I'll call it a few other really helpful client API methods. And so this is under the client API in the docs. Client, again, referring to the SDK side, the user side, endpoints that are available that can be authenticated with a session token. So the first one is, let's say you just wanted to get, you're building the client application and you want some more information about which client, which user in their wallet is connected by hitting just this this kind of get me endpoint. You can see all information about their wallets, what's the status of their backup shares, have they run a backup yet? Yeah, so you can get addresses for all of the chains. And Portal supports EVM chains, Solana. If you have any questions about chain support, let us know. But then some other cool ones is we have get assets. And this is what you can use to get the balance, essentially. If you're familiar with Web3 development, you'll know that you can just go ahead and send an RPC request to the chain to fetch the balance for a specific asset or your native token. But if you're not familiar, and again, that sounds like a lot, then don't worry about it. You can just hit this client endpoint, and we'll return all of the assets for that user. So you don't even need to ask, for a specific smart contract or a specific token. We'll just return all of it for you, and often with a bunch of helpful metadata. So if you're building an application, you want to show the user's balance, you want to add it up, you can go ahead and hit this endpoint. Then we also have a specific call out to fetch NFTs. So let's say you want to display users' NFTs. You can either just use this one get assets with the optional flag include NFTs set to true. So you can see that there's also now metadata about the NFTs, or you can call this get NFTs asset. And I would highly recommend, this is like a lot of data that's really helpful for building those kind of applications. If you're familiar with building Web3 applications, you'll see that this is like a lot more information than you'd usually get trying to build this out yourself, including, the image URL, a ton of metadata, and even market information about it, which is super cool for building more advanced applications. So a super powerful endpoint for building an application. And then the another couple cool ones. So one, get transactions. So if you wanted to show the history of transactions for that user's wallet, you can go ahead and use the get transactions, just specifying which chain you want to use it on. And then this returns a list of all of the information, all the transactions that they sent in the past. And then the last one I'll show over here, in evaluate a transaction. In this case, evaluate means either running a simulation or running a security check. And so you can set the flag to determine which one of those you want to do, but you basically pass the transaction in and you can verify it, whether it's, you can run a simulation to see what will happen if you want to present details to the user, or you can run a security check to make sure the transaction that the user is not trying to sign is malicious in any way. So yeah, these are super powerful endpoints to start getting and building your hackathon project. Cool. So that's some of the overview of the portal docs when available. There's a lot more on here if you haven't noticed. So again, just come back to this web. Let me open up one of these guide sections. Ton more information if you're looking for recovering across devices, information about how to set up backup or recovery, custom signature hooks I mentioned to display information to a user, integrations for swaps. eject, which I hadn't talked about yet. But Portal allows, let's say you have a user who wants to move, maybe they want to take their funds out of MPC. They're done using that. Well, they can actually eject their wallet. And obviously, very sensitive operation because it breaks the MPC promises. But you can return both those shares to the user device, and they can combine them to get a single private key, which they can then import into like MetaMask, into any other client wallet. But it is nice in case you like want to provide your users the guarantee they're not locked into your platform and don't want to take their wallet somewhere else. You can add that feature to your application if that's something you wanted. But then yeah, a ton of other resources here. If you're interested in account abstraction, you're familiar with that. Help information there, more information about our security scanning. But with that, let's go ahead and go to the Hackathon Hub. So for the hackathon, if you have any questions, go ahead and join us on our community Slack. All information is available in our docs here. And we'll hop on and help answer any questions. But also, if you're looking to get started building something, gone ahead and build repos in each one of our SDKs to get started. And so all of these are working applications that create wallets, have backup set up, and can send PYUSD to another user. So let's go ahead and pull open the web hackathon kit. So you can see this is a Next.js application. To get started on it, pretty easy. Pull down the repo, yarn dev, and put in your client API key into the config. There's a good walkthrough of like what all the different pages do and links to all that same helpful information. Let's go ahead and click through some of them just to see it in practice. Nice. So in this repo, we have just this provider here, little helper library. As you can see, as we showed in the docs earlier, this instantiating portal, simple as this. So in this case, we're pulling in the client API key out of our nvar first to simplify the development process. But a real application, you'd be fetching this from your backend per user. And then we'll go ahead and jump around to the first page. But by just instantiating that, and you can see down here, it'll call portal.createWallet if it doesn't exist already. You've gone ahead and created the shares for that user, and you can go ahead and get the address using helper functionality in the portal class. It's the get Solana address. Let's see if this will load. Here we go. Well, this is loading slowly. I hope I haven't been too choppy for everybody. Well, I can skip that for now. Oh, there you go. And we'll just load this. This is going to be a long wait for nothing super dramatic. But you can see this is just the main main page in the application. Use portal. So invoke this. We'll create a wallet for you if one doesn't exist. Like that's about it. It's going to use this load token functionality, which is going to use that getting your assets balance underneath the hood. and you can use that then to display an address for the user and what their balance is. And then on the signing page, to send your PYUSD to another user, pretty simple. You'll see it's just going to right here. So it's just going to call this send Solana token balances. Or this is this, sorry, this is the get token balances. The send should get invoked. Here we go. Send tokens on Solana. So really straightforward. Wraps around, and you can just call who you want to send it to, which program you want to use, and how much. And just like that, you can be sending PYUSD from one user to another. And if you, as you're developing, like I mentioned before, there's the PYUSD faucet and a Solana faucet to get test tokens for either one. So go here, you can get PYUSD on the Solana DevNet. You go ahead and here and request some Solana tokens on DevNet as well. But with that, that is primarily what I wanted to show folks to get started with PYUSD, Solana, and Portal. So I'm gonna go ahead and stop there and see if there are any questions.
Questions, guys. That's a lot to think. For sure, those who are those who are joining the PYUSD hackathon, you guys have questions for sure. So this is the best time. Our CTO is here. And he's starting recursions. Maybe while waiting, or maybe they're composing. Oh, okay, I got one. When calling the send token, do we use the ID of the PYUSD contract, or do we use the token 2022 program ID?
You'll use the token 22 ID, specifically the mint for it, to determine between yeah, and I believe, let me go ahead and pull up the docs, but I'm pretty sure for building the transaction this endpoint here, I think we have like a helper for it. So I think you can actually just define PYUSD. Yeah, it's not shown on the docs, but I'm pretty sure. Oh, sorry, it's evaluate. Build a transaction asset. So if you're using the client API and you're passing in the chains of Solana, and then you want to transfer an asset, you should be able to, yeah, you can use the token symbol to simplify here. So you can just say PYUSD for the token, and because you already passed in the chain, it'll do that mapping to figure out which address you're looking for.
Cool. Thanks, David. Hope that answers your question, Paul. Any more questions, guys?
If not, if you think of anything later, like I mentioned, please just go ahead and join us in our community Slack. We'll be able to answer any questions from there.
Right. Oh, another question. So suing the API is for a predefined set of curated tokens.
Sorry, let me see.
Oh,
The
using.
API is for predefined tree tokens. So yeah, great question. So you can use actually the API for any of the, if you provide the address of it, you can use it for any token. But we just have those like little helper names. So like if you didn't want to like put the contract address, let's say you're on mainnet or Polygon and you wanted to interact with the contract, a stable coin, we just put like a little helper there to shortcut it, and we have that mapping on our backend, so it's kind of easier to interact with. If you have the address, you can put that in there, and we'll format it all correctly. So no, not restricted to a predefined set, but made easier for the curated set. Awesome. And I see another question. How are the shares stored locally on the device? Great question. So it depends on which SDK. If it's a mobile SDK, it's stored in each operating system's secure method of storing stuff in their keychains. And for the web SDK, it's stored in local storage. And there's helpful architectural descriptions in the docs.
All right, cool. Thank you.
Cool. Well, I appreciate the time, everybody. Just posted those two links to the doc and to our community Slack if you have any other questions. But I appreciate the time, and yeah, let us know if you have any questions on how to get started.